A particle is in equilibrium under the action of three forces given by F1 is 3a over 30, F2 is 5b over 8 minus 8a, F3 is 1 over 3b. Find the values of the constant a and b. Well, if we've got two unknowns, we need to make up two equations. So we know the system's in equilibrium. So if we check the x components, and these must add up to be equal to 0. So we're going to have 3a plus 5b plus 1. And that has to be equal to 0 because the whole thing has to be in equilibrium. And then if we rearrange that, we're going to get 3a plus 5b is equal to minus 1. And then for the y components, we just need to check that 30 minus 8a plus 3b is going to be equal to 0. Rearranging that, we're going to get minus 8a plus 3b is equal to minus 30. So we've got two equations here. You're going to label them 1 and 2. We're now going to solve them simultaneously. I'm going to make the a coefficients the same, so I'm going to multiply the top one by 8. So that's going to be 24a plus 40b is equal to minus 8. And then I'm going to multiply this by 3, so it's going to be minus 24a, 3 times 3, which is 9b, and then minus 90. Then if I add those together, the a will cancel out, and I'm going to get 49b is equal to minus 98, which gives that b is minus 2, minus 98 divided by 49. Substitute back into 1. So I'm going to have 3 times a plus 5 times my minus 2 is equal to minus 1 because b is minus 2. That's going to give me 3a minus 10 is equal to minus 1. 3a is equal to 9. Therefore, a is equal to 3. So we're going to have that a is 3 and b is minus 2. Simple technique, two unknowns. We need two equations and then solve them. Admittedly, you could use the simultaneous equation solver on your calculator to speed things up in an exam. Okay, this has been a video to show you how to find constants when three forces acting on a particle are in equilibrium. I hope you understood, and I thank you very much for watching.